Hi, morning. My name is Erik Dörnenburg. I work at ThoughtWorks. We are a technology consulting company. I guess some of us know the name. We've pioneered concepts like continuous delivery, continuous integration. A few years ago, we started branching out into design as well, I think quite successfully. And today, I'm super happy to talk. Actually, I'm a software developer, but I'm talking about a topic that is not directly about writing code. It is about making it easier to write code. And that also involves a lot of insights from user experience design, from design. So it's really at that intersection of technology and design that talk is about. To get us started, a little admission, if you will. I mean, this is William Gibson, a picture of him, and that's what he famously wrote. I guess you have seen that quote a number of times already. He said, "The future's already here. It's just unevenly distributed." And that's actually what I do as a consultant. I'm not really inventing many things. I talked about pioneering, but most of the time what we do is we just go to one place and learn something and then go to another place and repeat what we saw there. And that is also what a lot of what I'm talking about today, that experience perspective, that's what I want to bring you today, to say these are things I've seen somewhere. This is not groundbreaking, and some of you might say, I've seen that somewhere over there, or that bit I've seen somewhere over there. That's totally to be expected. Now put yourself, if you are not a consultant, if you're a developer, into the shoes of a consultant. We often find ourselves sitting in rooms like that one that you can see over there. And now for a moment, think about the person who is just off the picture on the left-hand side. You can just see their laptop screen. They are from the business side. And when we have these conversations and we say, like, what do you really want? What is it that you need? They often these days, start talking about customer focus. We want a focus on the customer experience. It is not so much anymore only about having all the features or the cheapest price. It is a real competitive advantage to have good customer experience. So that's something they all want. What they also want a lot is responsiveness to the market. The markets, as we can all tell, over the past 3-4 years have become really, really unpredictable. Lots of things are changing. Businesses need to respond very rapidly. So what they are then saying from a more business perspective is to say, my IT solutions, the ones that I have in my organization, they need to allow me to respond quickly to market changes. And I will come back to that responsiveness quite a bit in this talk. And now we turn to the man on the right-hand side who is raising his arms there and talking. He's probably from the IT department. I made this up. This is a true picture, actually, but I made it up. I don't even know where he was from. So they will then talk about something like this. We want faster development. We just want development to go faster. That, of course, is linked to the responsiveness. If you can develop faster, you can become more responsive. But it is a more clear focus on what you want from IT. And then they often also talk about money. And they say, I want more efficient development. I want, with the same amount of people in my development department, I want to be able to write not necessarily more lines of code, not more code, but I want to implement more features, not only more quickly, but also more features. And something that we've seen here is it is not only about cost reduction. In many of the organizations I work with, the successful ones, IT is not treated as a cost center anymore. IT is understood to be something that provides value to an organization, that enables new business models or new revenue streams. That used to be quite different. I first saw this in the early 2000s in investment banks. They had understood this. They saw IT was really something that made them more money, and they were happy to spend a lot more in IT if they made even more money. And then for the last 20 years, the whole industry basically followed. And maybe you are in an organization which is still saying, we need to save costs in IT and our IT budget is low, without thinking what you could do maybe with a higher IT budget, without focusing on the top line. But anyway, this is roughly where most of the conversations start. And then some time passes, the conversation goes around those points, and suddenly we talk about IT. And then we are talking about cloud, cloud native, microservices. We talk about agile, DevOps, or oftentimes these days the Spotify model. And that's still somewhat connected, and I'll try to explain how. And then later, the topic of the talk, it will then go from there to platforms. I'll return to that later. Let's first have a brief look at those two boxes down there. what does cloud native mean from today's perspective? One thing I've seen increasingly with companies is they lift and shift. They take the existing application, a monolithic application, something has grown for 10 years plus, and they lift that up from their own data center, shift it over to the cloud and install it there, and then they replace the database that they're running themselves with a database provided by the cloud provider. That is not cloud native. Cloud native, to me, is something that is based on microservices, that has an architecture that actually uses the unique benefits of the cloud. And the original enablers that it allowed us to do microservices 8 years ago, they are still here. We still have virtualization, we still have the cloud, obviously, and I would say cloud is a much better way than virtualization. I've personally seen a lot of attempts to build private clouds in organizations, and I would say none of them has really been a success. Some of them were kind of scraping by, but most of them weren't really successful, and therefore I would say cloud is probably the one you want to do. What we're also seeing is that the benefits that people were talking about all those years ago, they really have materialized, and they're usually today very, very desirable. I mean, scalability is something everybody wants their business to grow, so if it scales, it's great. But then there's this other one, this responsiveness and cycle time to do something quickly. And that is what I talked about earlier, the responsiveness to the business. What does that mean? Here's a picture of Sarah Wells. She's a lead engineer at the Financial Times, and this chart shows how many deployments they did. And each bar is a day, and you can see they're literally doing more than 100 deployments every single day into production. And the Financial Times is not an outlier here. This is just a picture I took at a conference because it was a good way of visualizing it. I've seen clients that I work with in Germany, for example, that do the same, like 1,000 releases every single week. But why do they do that? Because they can, or because somebody said in a conference it's a good idea? No, there's a reason why they do this. And fundamentally, I have to do a little deep dive on this one here. That is the best way, or the best explanation I've found in talking to lots of people over the years about why that responsiveness has become so important. This thing here is a model called the Cynefin model. It was proposed by Dave Snowden in 1999 already. It got really popular in 2007 when it was featured in an article in Harvard Business Review. And what that talks about is different problem domains. Not how to solve a problem, but what domain your problem is in. I'm a consultant, there's quadrants, it's not a quadrant diagram. It's really about a progression from the bottom right to the bottom left around there. And as I said, apologies to Dave Snowden if he ever sees this. This is the very short summarized version by me, the 3-minute version. In the bottom left corner, we have the problems that are obvious. Here, I can see the problem, I can categorize it, and I know the solution. My summary would be, just follow the process. If it doesn't work well, you haven't followed the process. That is incidentally often the default thinking of many people who are in project management. If something doesn't go right, we obviously haven't followed the process. But it's only true for problems that are in that domain. In the top right domain, we have something where if you analyze enough, you can actually find the solution. You can predict the outcome of your actions. So here is what we do is we say, let's analyze this a bit more. And that's where a lot of us are the engineers, the experts live in. We believe if something failed, we haven't analyzed it enough. We could have prevented the failure if we had just looked more deeply. The problem, though, is that both with businesses as well as software engineering, that doesn't tend to work anymore. There's this thing called analysis paralysis. We're trying to figure out all these things, and yet we can still not figure it out in advance, no matter how much analysis we do. And again, we can be trapped by our thinking. We kind of live in that quadrant maybe, and we try to approach every single problem with the approach that is only suitable for problems that are normally rooted in this domain. What I would argue is that almost everything we do in software development today and in many businesses is in the top left quadrant. Here, the link between cause and effect exists, but you can only find it out in hindsight. Once you've done it, you know, oh, that is why that happened. This is the foundation of all Agile, where you say we do this in iterations. We find out what worked well, we repeat, what didn't work, we don't do. And this is where businesses need to be, and that's where IT needs to be. Has needed to be in the last 10 years, but especially now, where we want that responsiveness. And then it becomes clear why you want to reduce the cycle time. Because the more often you can go through, the more often you can try something and then figure out, oh, that worked, that didn't work, the better you can work. If you only do this once a quarter, you only have 4 times a year where you can check and course correct. If you do this several times a week, you have much smaller steps. So that's where we need to be. Take small steps and learn. The model also, again, like it's over 20 years old, said there is another quadrant. This is where I would argue most of the startups are, or some of the more speculative features. We just don't really know. We just try something. If it worked, and we're happy. If it didn't work, we try something else. But even in that one, you will also need short cycle time. You need to be quick, productive, and efficient as development teams. So I would argue most of the software development, not everything. If you're writing software for, say, a pacemaker in your heart, you're probably on the right-hand side. You need to analyze this carefully before. But most of the software we're writing today is firmly on the left-hand side, but a lot of the thinking is still on the right-hand side. So that's the shift we need to make, and that's where we need to go. Based on all of these ideas, over the years, I mean, microservices, we introduced the concept, it wasn't only ThoughtWorks, but I mean, Martin and James wrote the article in 2014. That's quite a while ago. But since then, we have seen really good emerging practices. We've seen engineering practices that work really well. Lightweight governance, evolutionary architecture, shift-left security are the 3 ones I want to mention. And I want to go a little bit into detail on all 3 of them. So the first one is, and I've mentioned this in many talks over the years, architecture is a really terrible metaphor. Architecture, when we write about software architecture, we borrowed this, and it always looks like this, having big plans, people chatting, and then creating a building, and you're done with it. This is not how software development worked. This is not, if I write a video game, maybe yes, even not today, that's not even true anymore. The game is finished, and it gets shipped to customers, and you can play it. But most IT software that we use in enterprises that are the foundation of e-commerce websites and so on, they don't look like this. They much more look like this. They look like a city. They grow over time. So town planning would be a much better metaphor for what we are actually doing. So how does that work? You don't have a master plan. You don't have an architect drawing this all up. This is a model of London, and of course the Romans didn't do this 2,000 years ago. This has evolved over time to suit the changing needs of the population. And that's exactly what IT should do. It should change over time to suit the changing needs of the businesses. And yet, most cities don't sprawl without control. There's not a single entity that plans every single building, every single chair in every single building. But there are rules. There are governance rules. There are people saying, this is an area that is residential, and therefore you must not build a factory in there. Or like in older cities, there could be an area which is said, these are all historic buildings. You can't demolish them. You have to keep at least the facades, or buildings need to look similar like that. So you have these rules. But they can also change dramatically. You have rules about traffic saying that is a big road that needs to be here, and now that we're turning away from cars in large cities, they actually change to public transport or bicycle lanes, and then there's different rules that govern individual aspects. And that's exactly what we want to do in IT. But how? How do we do it? Our CTO and 2 of my colleagues have written a book about evolutionary architecture, and I want to just explain one key concept, and that's one of the key takeaways from this talk as well. And they talk about so-called fitness functions. The idea comes from evolutionary computing, but I want to apply it, and that's what they did also in the book about evolutionary architecture, to IT. And as an example, take this video game. It's a video game about constructing bridges. As a player, you have to solve a puzzle. Here, you have to bring the red car from the left side to the right side, and you can build these funny bridges in the middle. And there's 2 fitness functions that are visible on the screen here. One is at the top. How much money does it cost to build that bridge? So all the elements, like the yellow ones, the red ones, the cables, the tarmac, they all cost money. And of course, the more you use, the more expensive the bridge gets. At the bottom is a competing, I hope you can all see that, at the bottom is a competing fitness function. And that says how much of the possible load the bridge can carry does it have to carry at the moment. When I took that screenshot, the car is in the middle of the bridge, and the bridge is loaded up to 64%. At 100%, at 101%, it will collapse. So here we have 2 fitness functions that guide the player. You should stay within the budget. That's a very binary one. Are you in budget or are you out of budget? It's 24,000 in this example here. The other fitness function says you must not exceed 100% because then the bridge collapses. But it doesn't tell you how to build the bridge. It doesn't give you rules of what the bridge must look like, what tools to use. It only describes the constraints you must act under. And importantly, as so many other fitness functions, there's competition between them. I mean, otherwise it would be boring, right? I mean, if there was no budget or if it didn't have to carry any load, then you would optimize one function. But in reality and in software architecture, usually we have to make compromises. We have to make trade-offs. We have to trade one thing against something else. And then those fitness functions help us guide it, and we can still have, like the town planners, some form of governance without describing exactly what software architecture to use. And that's the definition they actually came up with. I'll let you read this. And it takes me longer to open the bottle than for you to read this. So that's very abstract. I want to give you two examples. One is a very, very slow fitness function. And this is a slide that was shown at Apple's Worldwide Developer Conference in 2019. And at the bottom is a screenshot of Xcode, which is the IDE that developers use. You could argue a little bit of a developer experience platform. And what they can see is a summary of the telemetry data. So if you allow the iPhone to send telemetry data, they record the launch time. How quickly does the application launch? And the team can see here how the launch time developed over 8 versions of the application. And they could probably say 1.5 seconds is the limit, and at least anyway, it's really going up towards the end, and they can say, okay, our application isn't really fit for purpose. We have to change something about the application. We don't care what, but we have to do something to make the application launch faster. And here, with a fitness function like this that only happens in the field, you actually, again, want to be able to respond quickly, right? I mean, if this goes up too much, you don't want to wait for 3 months before you release the next version. You actually want to be able to respond quickly. The other question is, where does the data come from? And here also, we get an idea of a developer platform. The data comes... This is really great for a developer, right? The team can see this is the average launch time, but where does it come from? I mean, Apple here provides a large part of the developer experience. Otherwise, they would have to write all the code, they would have to get the data, install the backends, and so on. So here, this makes the developer experience better, makes the developers more productive. It's a fringe example, though. I mean, not that many people write applications for iOS. Another one, and I picked this because security is such a big topic at the moment, is a dependency drift fitness function. And I need to explain this. All your applications you write have dependencies, mostly these days. I talked to some guys from Google who will talk later today. They have a lot of stuff done in-house, but most of us actually use a framework like Angular or React, or on the server side we use a Java or .NET framework. And each framework today brings in more dependencies, and these dependencies bring in more dependencies. The typical JavaScript app, if you use React or Angular, you probably get 1,000 dependencies very quickly the moment you just include the application. And those 1,000 libraries that you're including will have security problems. It's not a matter of if they have one, it's just when that will occur. But that means if you're far behind, there will be security problems, so you need to deploy this quickly. And this is a real example from a client. When we went there, Angular 10 was the actual version that was out at the time. They had written the application when Angular 7 was released. And then you know the thing, oh, never change a running system, it works for us, we don't need the new features, we have no time. And they stayed on Angular 7 rather than upgrading to Angular 10. One of the first things we did, we ran actually NPM audit, which is built into NPM for, I don't know, years now, and it will just query the known vulnerabilities. And I hope you can see this at the bottom. It says there's over 1,000 known security vulnerabilities and 23 with high severity. So this is just from being three major versions behind on one of the most popular JavaScript frameworks. So it's a terrible idea. Keep your dependencies up to date, and again, from an architecture perspective, I don't want to tell the developers, I don't want to give them a window and say, you must always update, or you have a central team that always updates all the dependencies, but you can give them a fitness function that runs in their build pipeline and says, you are now 50 days behind the last version. Or you can say, the fitness function says, you have 3 minor security vulnerabilities and no major. And there you can again have governance in an environment where developers can still be autonomous, where they can work freely, but at the same time you can satisfy the constraints you need. And you give the developers a platform where they can work effectively and efficiently. And these supply chain attacks, I would say, I mean, if you haven't spent much time on them, that is the topic to look at in 2022. That is one of the biggest issues in security. It is not about websites being hacked from the outside. It is about the supply chains being attacked. And even in the Hazelcast talk, it came up briefly. Don't the hackers know something you use? And absolutely they do. And really be up to date on that. So, almost there. One more topic, shift left security. I guess shift left, if you have not come across this idea, your processes in diagrams often run from the left to the right, and security was often done at the end with pen tests. If you do 1,000 releases per week, of course you can't do a pen test 1,000 times a week, so you have to do something earlier in the process. Honestly, you can do an entire talk about this, and in fact I actually do an entire talk about DevSecOps. And I just wanted to give you the highlights here. If you want to take a picture or if you look at the slides later, these are really important topics to look into. But from today's perspective, from developer experience platforms, it also gives you an idea what you need or could or should include in your platform. So for example, secrets as a service. You don't want secrets in text files that are checked into source control. You want something like HashiCorp Vault, which is a product that manages secrets that the services need to authenticate to each other in a centralized, controlled way. Infrastructure as code. You can extend the concept to security policy. So in your platform, you probably want to articulate your security policy using something like Open Policy Agent and the Rego language to actually describe that, and that again make part of the developer experience platform to use. It carries on, if you look at the stuff we can run in the pipeline, linters, security scanners, dependencies that I just talked about, deployment fitness functions and so on. This can all become part of your developer experience platform and will all really help you to have a sensible amount of security that you need in today's world with the cloud native architectures with continuous delivery. So that was the blue box. The orange box I'm going to make shorter, it's more a tech talk, but I do want to briefly talk about it. So clients always say, we want agile. I mean, I'll come back to that at the very end. They want DevOps. I guess that has been so corrupted as a term that it doesn't mean that much anymore. But then they also want the Spotify model. And what does it really even mean? And I mean, ThoughtWorks and Spotify actually collaborate on a number of different things. I'll come back to that later too. So we kind of know that even Spotify say they don't really do the Spotify model. The Spotify model is just an idealization. And what it means, and I've tried to come up with different metaphors, it really tries to come up with this idea that you have a cross-functional or an interdisciplinary team, a small team, 10, 12 people that are autonomous, that can build a feature together. They have different roles. You don't have to have these unicorn, full stack, full spectrum developers. You can have specializations, but you need to have the right people in the team so they can work autonomously. The size, I mean, Amazon called them the 2 pizza teams from an American perspective, large pizzas. The idea was the team shouldn't be bigger than what you could feed with 2 large pizzas. They came up with the same number, roughly 10 to 12 people. If it's 14, that's fine too. If it's 6, that works as well. It's just an idea, right? But you want these autonomous, interdisciplinary teams. What is really important is, though, they need to have empathy for each other. I mean, if you have a person with testing, a QA background in there, you want them to understand about software development. If you have developers, you want to have them understand infrastructure and so on. You need that, really. And more so, actually, than in the movie example, which is also this interdisciplinary team that can actually shoot an entire scene. We do want to have a lot of overlap. I mean, we need to have a lot of understanding. And that, to me, still is the essence of what DevOps was all about developers and operations people working closely together, learning from each other, and getting the best out of their collaboration. But if you then go back to this one here, and they say, we want all of this. If you now think about what I talked about, all the microservices things, the practices, shift left security, the complicated pipelines, all the scanners in there, then the small teams of 12 people, that just isn't possible humanely. I mean, as I said, these full spectrum, full stack developers, they hardly exist, and if so, they probably have a good breadth, but do they really have all the depth? And does it make sense on an organizational perspective to actually have all the skills in every team? Do I need to have every 12-person team that is there to deliver business functionality? Do they need to know the last bit of the latest JavaScript bundling mechanism, as well as exactly how role-based provisioning works on AWS? I would argue probably not. they should really focus on using something, a platform, as I will argue, to actually build the business software. And then the question becomes, before in the Spotify model, you have something like guilds and chapters. And what I've seen in practice is that usually at some point you have an infrastructure guild. And that infrastructure guild kind of morphs into a team, and they look after all of these things. And in the end, what they do is then they build something that the teams can reuse. And that is then the platform. And that's what they need. They're saying, like, if we want all of this, and we are a sizable organization, we can't only have these 2 pizza teams, we can not only have these business teams, we need to have something, given the complexity of IT, that actually supports them. My former colleague, Evan Botcher, wrote about this in 2018 on Martin Fowler's website. And the title was, What I Talk About When I Talk About Platforms. And this is still, maybe I'm slightly biased, but for me, this is still one of the best definitions of this. And he wrote, a digital platform is a foundation of self-service APIs, tools, services, knowledge, and support. So here you get the first hint. It is not only about some technology. It is also about knowing things. It is also about providing people support. This is also super important. That's why he kept it in there, which are arranged as a compelling internal product. So these platforms aren't just platforms. You must view them as products. They're internal products. And they need to be compelling. I come back to that. They can't be just this ugly thing that the development teams are forced to use. They need to be compelling. And that's the result then. So the result is we have these small delivery teams, and they can develop at a higher pace. This is exactly what we wanted, the business side as well as the IT side. And the reduced coordination, of course, allows you to deploy more often because you don't have those dependencies. So, what does it actually mean? If we're saying we want to build these internal platforms, how do you apply product management to that? What can we learn from product management to apply to this? And the first one really is focus on developer experience. That is one of the, or probably the, and you can guess there's going to be a couple of points building up here, that is the biggest failure, to take this developer perspective into account, not treating these platforms as products, to treat them as a project, as a stepchild, if you will, to build, but not as a proper product, to not do the user research, to not look into this as a product in the same way we look at the product that we're actually building. And here's a real example from 2015, 2016. At the time, they went to a fully cloud-native architecture, and the platform engineering team, it was called that, PENG, Platform Engineering Team. And the leader of the team said, at the start of the project, we need to make sure not so good developers can't ship bad code. That was the guiding principle for the platform. And it utterly failed. They just put a lot of governance, almost like the fitness functions, but with a much stricter core set, with much more rules, into this. And it really didn't work. The teams found all sorts of reasons not to use the platform. They got exemptions of using different CI tools, and they really didn't want to do it. And frankly, the idea of, if you just have the right platform, you can hire bad developers. I mean, what does bad developer even mean? But I mean, even if you subscribe to the idea that some people are not as good as writing code, maybe they don't have enough experience. If you don't have a good team, the platform is not going to save you. But that's what they wanted to do. They thought that's what the platform does. 2 years later, and I'm kidding you not, 2 years later, they started saying, maybe we need to build a platform developers actually want to use or will use. And then, of course, a lot of things changed dramatically. That is when it clicked for them, and that's when they started to have the customer focus, and the customers here are the developers. And they started having a customer focus. They asked the developers, what do you need? The developers said what they need, and then things turned much, much better. Developers got more productive, and the platform was actually seen as something that helps. Also important is build and measures of success. And really, I don't want to give you good examples because it really depends on the organization. But to give you one provocative example, don't count the number of services or don't count the number of API calls. That's probably not what you want to measure. I mean, the easiest one would be to do an NPS score. Ask the development teams, would you recommend this platform to another developer? Do you like using the platform? And a lot of companies are scared about this. I remember, even with private clouds, I remember companies saying, but how can we force the teams to use the private cloud? And we're like, that's the wrong approach. How do we force them to use the platform? No, they want to use them and find out whether they do want to use them. And if the NPS score is bad, keep measuring it and find out what you can do to improve the score. Absolutely, they need to be self-service. If you see Jira tickets anywhere, run. I mean, if you have platforms where you need to open Jira tickets, it's not a real platform, because then it introduces lots of delays as well, bottlenecks in people and so on. You want the platform to be ticketless. You want the platform to be self-service. Focus on the value that is delivered by the platform. It's always a corollary of the previous points, but really think about, are we delivering value with the platform, or are we building something cool? So you don't want to do this. You don't want to build a Kubernetes cluster out of Raspberry Pis, or you don't even want to build a Kubernetes cluster in, like, say, Azure, or AWS, or GCP with 1,000, this container as a service things, with 1,000 nodes. That's not necessarily going to help development teams. We've seen this. I mean, you get a Kubernetes cluster, you don't know what to do with it, really, and then you get an AWS login with, like, I don't know, 3 IAM roles. And you're like, okay, that's great. What do I do next? So what we want from the platform is we want to provide value. It's almost like a pre-composed platform, like these accelerators. You want it to be easy to actually start a new microservice. A Hello World microservice should take 5 minutes. You should be able to take the platform and use something from there to actually build the business functionality and focus on that. That is the whole goal of the platform. The platform is not to have the largest Kubernetes cluster in the world. Because then when you have something that supports the team, you can go back to Evan's definition and to have something that allows the teams to develop faster. And then we're at that point, if you're building all of this, they need ongoing support. And this is what, I guess, in the end, we all come back to say, we need a platform engineering product team. We need a special team that is responsible for building the platform as a product. Their internal customers are the development teams, but their purpose in the company is to build the developer platform. This is one of the best summaries of a lot of modern software development practices. If you haven't read it, it's really, really good. Team topologies. And that's what they have to say about the topic. The purpose of a platform team is to enable stream-aligned teams, that's what they call the teams that deliver business functionality, to deliver work with substantial autonomy. So again, enabling. The platform team writes something that enables others to do work. They are not an ops team. And they're definitely not one of these weird DevOps teams, which is one of, I don't know what that means even. But I've seen companies where they relabeled the ops teams into DevOps teams, I don't know. But it's not that. They're not operating the services for something else. They provide a platform as a product that helps the other teams to actually write and operate their services in production. And then, almost like Evan, they mirror this and they actually quote Evan in the book. They say, that provides the internal services to reduce the cognitive load of the teams, and then we're back at where we were on the very first slide with the things that they wanted. This book has a lot of other really good concepts. It's not thick, as I said. If you haven't read it, it's definitely worth reading. Even if you're a Java developer and you're hands-down coding, it sounds very businessy and very organizational structure, but it's really super helpful. Even if it is just to talk to somebody in your organization that is responsible for organization design. When I asked internally and when we discussed these topics, there were 2 things that were mentioned that are super important for these engineering platform teams. And one was a roadmap. The platforms should have a roadmap. The development teams should know what is coming next. And the other thing that is absolutely crucial for the platform team is to have empathy. They need to understand the world of the software developers. And that is something I've seen done. I think it was mostly done by accident, but done beautifully with one of our clients. They had a classic thing, a big monolithic application that they wanted to go into microservices, but they also had before a development team and a separate operations team. This was 2014, so quite a while ago. And they said, we want to go to microservices, but we also want to try this new thing, DevOps. In 2014, that was only like 4 or 5 years old, so it was relatively new. And what they then did is they completely building the new services, they completely did away with any operations. They only did what we would call the Spotify model. They had software developers and former operations people, or still operations people, working together in these interdisciplinary teams. And then they really learned what they needed. So the operations people developed empathy for what the software developers needed. They weren't building these platforms that they imagined developers might need, the platforms that they thought we can make bad developers stop writing bad code. They really understood, working side by side with the developers, what they needed. And the developers, conversely, understood the concerns of the operations people of thinking, oh yeah, I don't have a debugger in production. I need to have some proper monitoring. I need to write log files at a pace that actually sustains across the system with high load and so on. So they really learned from each other. And only after that, they then created a platform team. So they didn't take the operations team and relabel it as a platform team. They went through this intermediate step to develop empathy for each other's roles by having everybody work together. And then once they had the empathy, then they said, okay, now we can specialize again, and now we can have a platform team that is looking after the platform. But now, because they had been working with the developers, they actually had all this ingrained, this idea of the developers are my customers, I need to build something that supports them, that helps them. And of course, the developers had more sympathy and empathy also for the people operating the platform. ThoughtWorks publishes this thing called the Technology Radar. By the way, the new edition, it comes out twice a year. The new edition will be out tomorrow morning. And over the years, we have said a lot of things. So if you want to read up on some of the concepts, we talked about this. We talked about platform engineering product teams. We also talked about ticket-driven platform operating models. This is the thing not to do. So the Radar also has advice of what not to do. So this is the don't have Jira tickets, make it self-service. And the Radar tomorrow, that will come out tomorrow, will also have something to say about building these platforms in an incremental way. You're not building the platform, you're done with it, and then you take that team and they write customer-facing products. The platform needs to evolve and needs to support, as Evan wrote, as the team topologies people wrote. And one thing, the Radar is divided into different categories, and one of the categories is platforms. And yeah, I know, platforms. And one of the things that we really like, and I want to give you an idea of, is Backstage. This is an piece of open source software that came out of Spotify. And we've used it a lot. We've helped companies use Backstage for themselves. And Backstage provides a lot of the things that a developer experience platform needs at the core. You don't have to do it. I mean, we've built similar things without using any foundation, stringing together existing tools. But given it's open source and it works really well, I can really heartily recommend it. So what we can see here is this templating idea. You can create a new microservice, like for example, create a React app. And you can just take it and it will give you something that is maybe hooked into your monitoring solution, that has the linters built into the pipeline, that knows how to build itself. So this really allows development teams to focus on writing the actual microservice, the actual front end of the application in this case, and not focus on doing all the boilerplate stuff. There's a whole lot to be said of how do you keep the templates up to date, if you change a template, what does it mean, and so on. But the idea is really clear. You want to have this, as I said, you don't only want to build a Kubernetes cluster, you want to make the teams effective and efficient, and then you can have templates like that, like a starter kit, if you will, and you can update them. And that, again, is part of the platform team. You can also have something like this. You have a service catalog built in that allows the teams to actually, when you look at an individual service, to see where the endpoints are, to get to documentation, rather than like, oh yeah, I know this is somewhere on Confluence, or yeah, the Swagger API documentation, where was that link again? You know, like this is a central point where you can go, and from there you can branch out into the different tools to find where the software is. Everything you really need to manage the lifecycle, also to find the monitoring endpoints to see something, because as I said, the development or the team that develops the platform, they're not there to run the services for you. They are there to provide a platform where the team can run the services. So they need to know, is my service working well? Do I suddenly get a lot of HTTP errors? Do I have long timeouts? Is latency going up? And again, here, you can have that central point where you can find that information. And then last but not least, in organizations, and when you have a lot of microservices, exploration can become an important topic. Do we have a service for this? What are the services in this space? I need fraud detection, like in the talk before. Do we have a fraud detection service already? Do we have maybe 3 of them already? Where do I find them, and so on? That's how you can explore a service catalog. I do want to say a word of warning here. It's actually not even mine. It is from Spotify themselves, but I can, and also from a ThoughtWorks perspective, we fully agree. Don't use this lightheartedly. I mean, if you have, like, say, more than 200 developers or more than 200 microservices, Backstage is a sensible choice. If you're a small team of 20 people, don't install Backstage. It doesn't make sense. It is really meant for large organizations with lots of services and lots of people. But if you have that, in our experience, it is the best tool to get started with as the seed, if you will, for that part of a developer experience platform. One more thing towards the end. As much as we can talk about all these topics, about Backstage, Kubernetes, and so on, I would say from a developer experience perspective, the fundamentals still matter. The secret sauce, you know, like you can make the best burger, but you need that secret sauce in it. That is still there. And there's still test-driven development is one of the most, or if not the most important thing. Test automation, if you don't have it, start there. Don't build a fancy developer experience platform. If you want to improve your developer experience and you're not doing test automation, that is the thing you want to start with and invest time in it. I don't know whether you know that case study from HP. It's about the laser printers, and they had about 5% what they called research and development. That's how much time the team spent on actually writing new features. 95% were from merging code, different product lines, and all these other things they needed to do. And then after transformation, they actually ended up with 40% of their development time, of their time being able to develop. So they increased it from 5% to 40%, an 8-fold increase. But how did they do it? They invested 23%. I mean, it wasn't a conscious choice up front. They measured it. But they invested 23% in test automation. But now think about it. If you had been going into HP and said, you only spend 5% of your time actually writing new code, the rest is all about operating, merging, and all these things, why don't you invest more than 20% of your time automating tests? They would have said, you're crazy. We only have 5% development time. How can we spend 20% of the time automating tests? But it really, really works. It really works. Automate your tests. You will get that investment back many, many times over. There's great articles. It should be a test pyramid, you know, like the little user acceptance test, the ones that remote control the web browser, the snapshot testing, very few ones at the top, like the food pyramid, only a bit of chocolate, and lots of veggies at the bottom. So TDD and so on, like the unit tests, actually, that is the basis of what you need to do. That's number one. Number two, continuous integration. And continuous integration does not mean installing Jenkins on a branch. It's so crazy. I mean, this is just the opposite of what continuous integration is. Continuous integration is not about installing a CI server. And I'm saying this in a talk about developer experience platforms. Yes, you do want to have infrastructure to run continuous integration pipelines and continuous delivery, but that doesn't mean you're doing continuous integration. Continuous integration, and this is a definition from Wikipedia, it says, is the practice of merging all developers' working copies to a shared mainline several times a day. This is not working on feature branches. This is what CI really meant and still means. And given that we have some time, I'll show you something funny. This made the rounds a while ago, like a few weeks ago. I don't know, you might have also seen it. It was started by somebody reading a history book and then posting it on Twitter, and then it went on to Reddit and so on. And on the right-hand side, that's Ada Lovelace, arguably the first programmer in the world in the 1840s. And she programmed the computer that Charles Babbage had created. And she writes this letter in 1843. She's very confident. You can see this in the paragraph. I wish you were as accurate and as much to be relied on as I am myself. So there's no lack of confidence. And then look what she writes. She's the first programmer, really, the first programmer in the world. I hope you do not take it upon yourself to alter any of my corrections. So here again, we have the idea of, oh yeah, you give the code to somebody else who reviews it, make changes, and she's like, no, don't mess with my code. And then she says, you've made a pretty mess and confusion in one or two places, so she disagrees with that. You've made a mess before. I think her communication style is very blunt. I mean, I don't know, that's probably not how you would communicate in today's world. Your emails wouldn't look like this. But the idea is still the same. So if we take the imaginary great-great-great-great-great-granddaughter of Ada Lovelace, she'd probably say today, could you not just merge my PR, right? And again, this idea, when this came around, one of my colleagues said, async code reviews have sucked since the beginning of time. So we see this like in 1840, somebody's doing a code review and complaining about it, and we still see the same thing today. There's so many incentives actually for both the reviewer and the person who is writing the code to actually not do a great job. And it just doesn't work, and it holds up, it dramatically increases your cycle time. If I look at something like the Financial Times or the big e-commerce sites we work with, for example, when you do 1,000 releases per week, you actually want to ship the code, you want to commit it, you want the pipeline to run in, say, maybe half an hour and actually deploy into production. If you work on a branch, The first thing is you have to merge the branch. And depending on how long you have worked on the branch, merging becomes difficult. That's the whole thing that was documented many years ago in great detail, why that is actually a difficult thing to merge, because you have all the changes and somebody else merges something while you are merging, and then you have to merge their merges and so on. That takes a lot of time. But also then, if you do a code review before that, then you have to wait for somebody to do the review. And then you're not looking at 30 minutes between checking in and production, you're generally looking at a day or two. And that's an order of magnitude slower. So what I would argue is do continuous integration, do continuous delivery, ship this thing, but don't do these branches, don't do these code reviews. If you need 4 eyes on code and understand good reasons for that, use pair programming, try that. Don't assume just sitting down it will just work. It needs to be learned. There's a lot of good material out there to say how you can do it. But these code reviews, they've really sucked from the beginning of the time, and they still suck today. Something else that is super interesting from a developer perspective is Scrum. Somehow, companies wanted to be agile, and I've mentioned this here, and I've heard it so many times. But in the end, most companies were very process-oriented. If you think back to the Cynefin diagram that I showed you, remember the model with the 4 quadrants? They often live on the right-hand side. If it doesn't work, follow the process more closely. Their value system is based on processes. So when they turn agile, they stay within their paradigm and they stay process-focused. They're just swapping out Prince2 with Scrum. And then they say they are agile, but they're not. The problem is that agile is based on values, but it's really, really hard for companies to do that paradigm shift. But it has a profound impact on the developer experience. No matter whether you have the greatest platform or not, if you have these models, or even worse, if you use SAFe, which is more of the bad thing, and you think that is all of agile, then it really doesn't work well. And interestingly, this post was written about a year ago. Somebody looked at what the large and arguably successful tech companies are doing. They are agile. They use a lot of this. I mean, Google, for example, and I don't know as much about Amazon, they have great developer experience platforms in-house. They do all the things I talked about, and yet there's no Scrum to be found. This is not to say that Scrum is bad per se. In the engagements we do with our clients, we often use practices like burn-down charts, we use practices like stand-ups and estimation sessions and so on, but it's just a few techniques you can use, but it's not the end goal. The end goal is not to do agile with a capital A, not to do a process, but to be agile. In the true sense of the English word, to just have this agility. And that is also my parting word here. The agility you want, that is what you get from the developer experience platform. The developer experience platform allows the developers to focus on writing business code, to be faster with that, and to be more efficient, and that allows the business on the whole to become more agile, to be more responsive to the market needs. And that is what I showed you on the first slides, the business actually mostly wants. They don't care about a process, they care about the agility of their business. And with that said, thank you. That's Slido again, and I have some time, I guess, for questions. Ooh, I can see lots of questions already. I can take this in 2 parts. Let's start with the tickets. I think I tried to explain it. The problem with tickets is it takes too much time. If you need a change in a firewall and you have to open a ticket, you're guaranteed to take at least 15 minutes. It can take days sometimes to make a change. What you want on those developer experience platforms is you want self-service. You want to be able to say, I need to have that change, and the change is actually made. And then you're like, oh my God, this is chaos. If the developers can make all the changes, but that's where the fitness functions come in. That's where security policy as code comes in. You can make the change if it meets the policy requirements, but they're all automated. So the idea that's wrong with tickets is it involves human beings and it takes too long. What's wrong with Jira is a whole different talk. I'm not going to go into that. How does a self-service platform look like in practice? That is what I try to explain with Backstage. Backstage is, as a starting point, a good developer experience platform. That's, if you want an example of something that is very polished, for large-scale teams, go there. A smaller one, as I said, could even be, to say something nice, could be a Confluence, based approach. We've done this years ago to actually implement certain services that are linked from there or even embedded into pages. It could be something where you can go again without a ticket rather than saying, I need an environment for a new microservice where you can just click somewhere and then it returns you some AWS credentials and you can log into AWS and everything else is provisioned. That is also a platform, if you will. Anything that allows the developers to focus on writing the business relevant code. To deliver, we want to use pair programming instead of async code reviews. Yeah, I said that is one possibility to do. Async code reviews have lots of problems. I mean, oftentimes the person who writes the code thinks they're under time pressure and they're like, yeah, I'm not really sure about this. I'm sure the reviewer will have a close look at it. If I made a mistake, the reviewer will find it. The reviewer is also a developer. They're also under stress. They also have lots of work to do, and they're like, oh God, I have to do another code review. And then they're like, yeah, I don't know, James wrote this piece of code. I know James is a good developer. I probably don't have to check too closely. I'm sure this is going to be all right. That is how the incentives work for both sides to not do a thorough review. On top of that, there's a lot of political issues about people having biases, not liking each other, communicating in almost the Ada Lovelace style, and saying, you made a mess of this, bug, like things about like you missed the formatting and I like the formatting that way and all these things. It really is just a feeding ground for a lot of inefficiencies. You can work on your own, but as I said, I mean, one way of actually having that benefit of having 4 eyes looking at code and developing, in my personal experience, is pair programming. I'm not saying you have to do it, but I'm saying async code reviews are known to not be very effective. Fitness functions applied to work already done, but how to steer the work into the right direction from the beginning. The idea is to make the right thing easy. So for example, on the fitness functions, many of the things that you can run in the pipeline, you can also run in the IDE already. So for example, if you talk about code style, or if you talk about things that find potential security issues like SQL injection attacks, there's already the same tools that can run in the pipeline afterwards. They can run in the IDE and alert the developers while they're writing the code. And then also to steer teams in the right direction in the first place, that is exactly where the ideas of the platform and the template comes from. So if you don't give anything to people and say, the only mandate is use Java, they can install all sorts of things. They can use all sorts of libraries and frameworks. They don't really know how to hook into the observability platform and so on. But if you give a template, then you're steering them in the right direction because they get this empty template, a hello world, and they can start writing the code, so they're doing the right thing from the start. So making the right thing easy and guiding people automatically to do the right thing is the best way of steering this. How to keep the code clean. What is a CR? How to keep the code. I mean, as I said, you can have linters in the pipeline. You can actually check whether the code is good. But I mean, what does it actually mean? What does it say about your confidence as a manager in the development team? So the people will not write clean code unless they know it's reviewed? Don't you have a value problem in the company? I mean, what does it mean? Or do you have developers who can't write clean code? You have 10 of them and one person who knows how to write clean code, and he needs to review the work of all 10? Is that the best way of using that developer who can write clean code? Wouldn't it be better to have that developer teach the other 10 how to write clean code? Why do you believe that a code review is the only way to write good code? That is exactly the same thing on a smaller scale that the company did, who said, our developer experience platform, we need to make sure not so good developers don't ship bad code. You can't do it in the platform, and I would argue in the same way that it's really, really hard to do it with code reviews. Work with people before so they know how to write good code. And if they don't write good code without knowing somebody will review it, speak to them. Find out why they're not doing it. This is the empathy again. This is understanding your people, increasing the developer experience. I swear, no developer wants to write bad code. We are all proud craftsmen or craftswomen. We are not here to say, oh yeah, I'm going to write some shitty code today. And I'm only not doing it because I know somebody will review it. Okay, we're out of time. I'm going to hang around for a while. Catch me. Thank you.